I'm about to show you something that most nurseries genuinely don't talk about. And I want to be upfront that this isn't the miracle in a bag story some gardening channels turn it into. A powder you sprinkle into the planting hole when you put a new tree or shrub in the ground. That establishes a relationship inside the root system that can mean the difference between a tree that struggles for 3 years and a tree that never looks stressed at all. This isn't fertilizer. It contains almost no nutrients of its own. And if you're expecting it to work like a bag of nitrogen you'd buy at the garden center, you're going to be disappointed. It doesn't feed the plant directly, and it doesn't work the same way in every situation. Which is exactly the part I want to walk you through carefully, because I'd genuinely rather you understand when this helps, and when it does, basically nothing, than have you buy a bag, dump it in, and wonder 6 months later why nothing seemed different about your tree. The product is mycorrhizal fungi inoculant. You'll find it at garden centers labeled as root booster, transplant fungi, mycorrhizae, or sometimes just as a small additive packaged with tree planting kits, usually in a small pouch or bag that costs somewhere between $10 and $20, and treats dozens of individual plantings, depending on the size of the bag. Most people who see it sitting on the shelf next to the fertilizer spikes have no idea what it actually does or why it's priced the way it is. And most of the people who do buy it never learn why it worked for their situation or why it apparently did nothing at all. Before I tell you exactly how to use it, I need to explain what's actually happening underground when a plant's roots interact with soil. Because this determines whether adding this powder is going to make a real, measurable difference for your specific planting, or whether you're about to waste a perfectly good $10 on something your soil already has plenty of. Let's talk about how tree roots actually function in real soil, because most people picture a root system as just roots reaching down and pulling in water and nutrients directly in a healthy, undisturbed forest or grassland that hasn't been graded, tilled, or stripped. The vast majority of established trees and shrubs have their root systems physically colonized by microscopic fungal filaments called hyphae. These fungi form a genuinely symbiotic relationship with the plant, not a parasitic one. The fungus receives sugars that the plant produces through photosynthesis and has more of than it strictly needs. And in exchange, the fungal network extends the plant's effective root system dramatically, sometimes by a factor of 10 to 100 times the surface area the plant's own roots could cover on their own. The fungal threads are far thinner than the finest root hair and can physically access soil pores and mineral surfaces that roots are simply too large to reach, pulling in phosphorus, nitrogen, zinc, and water from a much larger volume of soil than the plant's own root system could ever explore alone. This relationship, called mycorrhizae, is not some exotic or rare biological arrangement limited to a handful of plant species. It's the default state for the overwhelming majority of land plants on Earth, and it's been documented in fossil evidence dating back over 400 million years, essentially as old as land plants themselves and predating almost every other complex terrestrial ecosystem we know about. Some researchers argue the relationship was a prerequisite for plants successfully colonizing dry land in the first place, since early plants lacked the deep, extensive root systems that later evolved, and would have depended heavily on fungal partners to access water and nutrients in primitive soil. Trees in an established, undisturbed forest are almost never operating on their root system alone. They're operating on a root system extended by an underground fungal network that's frequently connected to neighboring trees of the same or even different species as well, sharing nutrients, water, and even chemical warning signals about pest attacks between individual trees, in ways that forest ecologists have only started to properly document and understand in the last few decades of research. Here's the part that matters directly for your new tree or shrub. And it's the part most nursery customers never hear explained clearly. Soilless potting mixes, the bagged material most nursery stock is grown in for the sake of consistency, weight, and disease control, do not contain mycorrhizal fungi as a general rule. It's simply not present in sterilized, peat-based or bark-based commercial growing media, the way it's present in real forest or garden soil that's been left undisturbed for years and allowed to develop its full biological community. A tree grown in a plastic container at a commercial nursery for 2 years, then sold to you and eventually planted in your yard, very often arrives with a root system that has never once formed a mycorrhizal relationship in its entire life up to that point, because it spent its entire growing period in soil that had no fungi present in it to form one with, regardless of how healthy and vigorous that tree might otherwise look above ground. Stay with me, because this gap between nursery soil and your actual yard is exactly where the inoculant either matters enormously or barely matters at all, and knowing which situation you're in is really the whole point of this video. If you're planting into soil that has been recently disturbed, graded, or brought in as fill, new construction sites, heavily tilled garden beds, compacted urban lots where topsoil was scraped away during development and replaced with subsoil or imported fill, the native mycorrhizal fungi population in that soil is often severely reduced or completely absent. Management practices like repeated tillage, heavy chemical fertilizer application, fungicide use, and topsoil removal are all documented in the research literature to significantly reduce or eliminate mycorrhizal fungi populations from soil that once supported them perfectly well. In this situation, adding an inoculant genuinely reintroduces something your soil has lost. And the plant you put in the ground has a real meaningful chance to form the mycorrhizal relationship it would have formed naturally if the ground hadn't been disturbed. If you're planting instead into an established garden bed, an area near mature, healthy trees, or soil that hasn't been heavily disturbed by tillage or construction in years, there's a very good chance native mycorrhizal fungi are already present in that soil, and already fully capable of colonizing your new plant's roots without any help from a bag at all. Research on this exact question found that a large majority of test tree roots showed some existing colonization by native mycorrhizal fungi, even before any commercial inoculant was ever applied to the site. Multiple university extension studies, specifically examining landscape trees, found no measurable additional growth benefit from commercial inoculant products, when those products were applied to soil that already had healthy native fungal populations established. Precisely because the native fungi were already doing the entire job before the bag was ever opened and the powder ever touched the roots. This is the honest, genuinely complicated truth that most marketing for these products conveniently skips over. Mycorrhizal inoculant is not a universal growth accelerant that works identically every single time, regardless of your soil's actual condition. It's a targeted solution for soil that has specifically lost its native fungal population through disturbance, and it does very little measurable good in soil that never lost that population in the first place. So how do you actually know which situation you're in? There's no simple home test kit the way there is for soil pH or nutrient levels, but there are strong practical indicators you can use. If your planting site is new construction, was recently regraded by heavy equipment, was tilled repeatedly for row crops or vegetable production, or has been treated with fungicides on a regular schedule, assume the native mycorrhizal population is genuinely compromised, and an inoculant is likely to make a real difference. If instead you're planting near established mature trees in a garden bed that's had compost and organic matter added consistently for years without heavy tillage disrupting it, or in soil that's clearly already supporting healthy, thriving plant life on its own, the native fungi are probably already present and already doing their job without any need for you to add more. Here's exactly how to apply it correctly, because the application method genuinely matters as much as the decision to use it at all. And a lot of people who buy this product apply it in a way that reduces its odds of working before it ever gets the chance. The single most important detail with mycorrhizal inoculant is direct root contact. The fungal spores in the product need to physically touch the plant's actual root system to have any realistic chance of colonizing it and beginning that symbiotic relationship. Sprinkling powder loosely on top of the soil after the plant is already in the ground and covered, or mixing a small packet broadly into a large volume of backfill soil where it gets diluted across a huge area, dramatically reduces the odds that any individual spore actually makes contact with fine root tissue at the exact point where colonization would need to begin. The correct method is to apply the powder directly onto the root ball itself at the precise moment of planting, before the hole gets backfilled. For a bare root or container-grown plant, dust the powder directly onto the exposed roots before placing the plant into the hole, working it gently into the root mass with your hands so that it makes physical contact with as much root surface area as possible, rather than just resting on the outermost visible roots. For larger root balls, where you can't easily work powder into the interior, you can also dust the sides and bottom of the planting hole itself, so that as the plant's roots grow outward from the root ball over the following weeks and months, they immediately encounter fungal spores waiting at the edge of the disturbed soil. A light, even dusting, is genuinely sufficient for this purpose. More product does not meaningfully improve the odds of successful colonization once you've achieved good thorough root contact. This is in a situation where doubling the application doubles the eventual benefit, so there's no advantage to overdoing it. After planting, water the area thoroughly and consistently. Since the fungal spores generally need reliable soil moisture to germinate successfully and begin forming the physical connection with the root tissue, avoid applying heavy synthetic phosphorus fertilizer in the same season as your inoculant application, because high phosphorus availability in soil actually suppresses mycorrhizal colonization directly. The plant has measurably less biological incentive to invest energy in maintaining the symbiotic relationship with the fungus, when it can simply pull phosphorus directly from an abundant, easily accessible soluble source in the soil water instead. This is a specific, easily overlooked detail worth remembering if you're running both a fertilizer program and an inoculant application at planting time, because the two practices can genuinely work against each other if your fertilizer choice is heavy in phosphorus content. Now let's talk honestly about what results to actually expect. Because grows 3 times faster is exactly the kind of claim that shows up in marketing copy and dramatic thumbnails, but doesn't hold up as a fixed, reliable multiplier when you actually look across the research. What the research does support, consistently, and across many separate independent studies, is a cluster of specific, real benefits that show up reliably in situations where the soil genuinely needed the fungi reintroduced. Documented benefits include measurably improved drought tolerance, better performance under salt stress conditions, increased resistance to certain soil-borne root pathogens, and, this is honestly the one that matters most for a newly transplanted tree in your yard, significantly reduced transplant shock. Plants with an established mycorrhizal relationship handle the physical stress of being moved from a nursery container into open ground measurably better than plants without one, because the fungal network is already extending their effective root system out into the surrounding soil before the plant's own physical roots have had time to grow out and establish themselves. Growth rate improvements do show up in a meaningful number of individual studies, particularly in disturbed or nutrient-poor soils where the comparison against untreated controls is stark and easy to measure. But the size of that improvement varies enormously depending on the plant species involved, the specific soil condition at the planting site, and which fungal species happens to be present in the commercial inoculant relative to what that particular plant naturally partners with in the wild under natural conditions. Some published studies on aspen and poplar seedlings found real measurable improvements in nitrogen uptake and overall growth from inoculation carried out in controlled nursery settings. Other studies, looking at established street trees like willow oak and live oak, found no measurable growth or survival benefit at all from the same broad category of commercial product, tested under otherwise similar conditions. The honest summary of the actual research literature is that mycorrhizal inoculant is a real, scientifically supported tool with a genuine mechanism behind it. But it is not a guaranteed growth multiplier that applies the same way to every planting. And anyone promising you a fixed number like 3 times faster growth, regardless of your specific soil condition, is oversimplifying a picture that the actual peer-reviewed research treats as considerably more nuanced. Here's what happened when I actually tried this on a planting of my own, and I'll give you the honest, specific result rather than a dramatic one dressed up for a thumbnail. I planted 3 bare root fruit trees on a section of yard that had been graded and had fill soil brought in 18 months earlier during a drainage project, which is about as close to the textbook disturbed soil scenario as you can realistically get in a residential yard. I inoculated 2 of the 3 trees at planting time, dusting the powder directly onto the exposed roots before backfilling, and I deliberately left the 3rd tree untreated as an informal comparison, so I'd actually have something to compare against rather than just guessing. By the end of the first full growing season, the 2 inoculated trees showed noticeably less transplant stress overall, visibly less leaf scorch during a particularly hot, dry stretch we had in August, and both of them pushed a second flush of new growth in early fall that the untreated tree simply didn't produce at all that year. The untreated tree survived just fine and looked completely healthy by the following spring, but it had visibly lagged behind the other 2 through that entire first difficult season, taking noticeably longer to establish and looking stressed at points when the other 2 didn't. I wouldn't call it 3 times the growth by any honest measurement, and I'm not going to pretend it was. I'd call it a noticeably easier and less stressful first year for the 2 inoculated trees, which, for a newly planted tree going into disturbed fill soil, is exactly the kind of realistic benefit that the actual research predicts, rather than the exaggerated version that gets sold in some of the more dramatic gardening content out there. One honest closing note before I let you go. If you're planting into soil that's already healthy, already growing things well without any help, and hasn't been disturbed by construction or heavy tillage recently, save your $10 entirely. The native fungi are very likely already present in that soil, already colonizing your new plant's roots on their own natural timeline without any assistance needed. And a bag of inoculant added to soil like that is solving a problem that simply doesn't exist in your particular yard. Save the product instead for the situation it was actually designed for. New construction lots, heavily tilled vegetable beds, and soil that's been visibly stripped, compacted, or chemically treated in ways that would have wiped out the native fungal population. That's exactly where this genuinely earns its cost and where you'll actually see the difference the research describes. If you found this genuinely useful, watch the next video and don't forget to subscribe. See you in the next one.